anything from Jen? Oh, there we go. Normal Lockyer Jen. Jen. That's that. Got that.
I just got a notification that normal Lockyer Observatory is live.
Oh.
Okay, so what we do, Alex, we're going to start off a short talk now.
Okay, yeah.
Then you can have them. And then Dave's going to take the live stream.
Yeah.
You will be able to share, do a talk.
Yeah, no problem.
So you do the lock here, perhaps the Kensington, and then I'll do.
Yeah.
What you see.
That's good. So I'm not playing. Was a bit of getting more people than last time. Just because they can't see. Okay, thanks. Oh, please, yeah.
Basically, it shows, that's the way to say it.
Now, he's, so it's good. Yes.
No. They looked at the box.
Yeah. Mine is really great. And then after that, anyway, come to the story why I want you to go.
No, perché non si può dare di contare. Se ti vuoi che cazzo si
Okay, folks, welcome everybody on Zoom and YouTube. We're at the Lockyer Observatory tonight, and we welcome Sidmouth International School, who've joined us for this evening. Unfortunately, unlike last night, the skies are cloudy, but we will do our best. We'll show you what sort of things are in the sky. So without further ado, we will press on. What we were hoping to do is live stream through this telescope. We go back. Live stream through this telescope, which is Celestron. 11-inch Celestron with a little finder scope, camera, and ASI Air Plus, which connected through Ethernet cable to our lecture theatre where we can image. We had reasonable success last night. We saw Jupiter and Saturn, a few planetary nebulae, and a little exploding comet. So, what's up in the sky tonight? Well, if you had it been clear, you would have seen the main gas giants. You've got planet Saturn in the south and Jupiter rising in the east at the moment. Stretching from the southwest to northeast sky, of course, we've got the Milky Way. If I put in the constellation shapes, you can see all the different constellations. We've got Aquila, the Eagle, down there in the south, with bright star Altair. We've got bright star Vega, Deneb, making up the Summer Triangle, which crosses the Milky Way. And then running through the Milky Way, we come to the famous W, the Cassiopeia, and the Vein Queen in the sky. And dropping down to the northeast, we've got Perseus. The most prominent constellation at this time of year, of course, is the big square of Pegasus. And that from the top left-hand star, we get the little constellation of Andromeda running off from that. So that's basically in the sky at the moment. I'm going to show you some now pictures we've taken recently with this little telescope. As I said, it's controlled by a little Raspberry Pi computer that rides on the telescope that grabs images from the camera. And this little camera here is the Guy scope camera. Planet Jupiter, of course, is a wonderful gas giant, 88,000 miles in diameter. This is a picture taken in a month ago showing a great red spot. Now, this had been visible from the early 1700s, but it was a lot larger then. It's now shrunk to about 10,000 miles. And it is basically a vast anticyclonic storm on Jupiter. It rotates anti-clockwise around this way, and it is basically its red color is due to a lot of methane compounds in the atmosphere. All the dark bands you see, these are called belts, the dark belts, and the lighter areas are called zones. And the belts probably sit lower down in the atmosphere of Jupiter, and the great red spot, there's probably there's a huge vortex, so that penetrates quite deep into the atmosphere. The other thing you'll see are little white ovals. These travel around the planet at different speeds of the equatorial region. Jupiter rotates very quickly, in about 9 hours, 50 minutes. And so the fastest moving region is what we call the equatorial zone here. And in the equatorial zone, you quite often see these blue festoons. All these features change quite rapidly. So from one day to the next, you'll see some of these features die out. The little white spot here is the moon Io. That's in transit across Jupiter. Sometimes you'll see it with a little shadow following. That will be called the shadow transit. That's the sunlight shining on the moon, casting its shadow on the tops of the clouds. And of course, Io is a highly volcanic moon of Jupiter. There's probably about 200 or 300 active volcanoes on this little tiny moon. Next planet out, of course, is giant planet Saturn, with its wonderful ring systems. These are probably caused by a moon of Saturn that was collided into and smashed up into lots of different particles. The black gap you can see here is called the Cassini division. We were just able to see that last night through our images. It didn't show up very well. The seeing conditions weren't all that good. but this was a photograph taken a month ago under quite good seeing conditions. So they're the main planets on view at the moment. If we go further out into space, we can come across an exploding comet. This one is called 12P Pons Brooks. Comet is named after its discoverer. So it was a Frenchman, Jean-Luc Pons, who discovered it around about 1813. And it was recovered probably about 70 years later by Dr. Brooks. So they're basically they share their name to it. Now, what's remarkable about this comet is it is a Halley type comet, so it comes around about every 70 years, and it brightened very quickly. Just a few days ago, on October the 5th, and now shows these twin horns. It looks very like the Millennium Falcon spacecraft from Star Wars era. But the surprising thing is, when comets normally outburst, they're quite close to the sun, that generates the heat that causes the evaporation of the ice and water. But at the moment, this comet is so far from the sun, so we can't explain that the energy from the sun is causing it to explode. I think it's more likely to be like a case of cryovolcanism, like the collapse of a cave on the nucleus of the comet, causing this expanding coma. But this comet was actually exploded last July. So it was 4 astronomical units, that's 4 Earth distances from the sun. And again, we saw this horseshoe-shaped coma. And they worked out it was probably caused release about 10 billion kilograms of dust and ice. And this coma expanded. Each day you saw it getting bigger. So the coma expanded about 600,000 kilometers by the 5th of August. Here's a picture taken on the 5th of August showing it expanded. Of course, as it expands, it gets fainter. So throughout September, it had faded, but it's only recently again exploded. This was a picture we took last night through the Victoria telescope, again showing its horns appearing. So it's a bit of a mystery. We don't know exactly why these 2 horns are appearing. You would have thought it was a single explosion. It would just be one single spike coming out of it. So rather mysterious comet Pons Brooks. Here's a nice star chart, courtesy of Dave Eagle from stargazing.co.uk, showing the passage of this comet. Here we are in October. You can see around about Christmas, it passes very close to the bright star Vega. And then it comes through Cygnus in January and on through Lacerta north of Pegasus in February. The comet is actually brightest next April. So we're expecting this to be probably a certainly binocular comet by next April. There's another comet in the sky. This is comet 103P Hartley, lovely blue-green comet at the moment in Gemini. And this will steadily brighten over the next few weeks as it's just passed closest to the Earth. Just the start of a little narrow iron tail coming out here. Going further on out into space, these are some pictures taken from the Victoria telescope. This is the famous Dumbbell Nebula. This is the star that exploded probably about 6,000 years ago. It's seen at a distance of 1,360 light years. And the generic name for these exploded stars are planetary nebulae. This little star in the center here is the white dwarf. That's a very dense object. Probably something the size of the mass of the sun, with a diameter of planet Earth. They're very massive objects. So a cubic centimetre of that will weigh about a ton. Here's another one. This is the one we imaged last night. This is a famous ring nebula. Again, another planetary nebula seen at distance about 2,500 light years. And you can also see a little galaxy in the distance. This is obviously far more remote. And this is millions of light years away. This object is just 2,500 light years away. Another planetary nebula, this one's called the Blue Flash. This is probably what's called a bipolar planetary nebula. It's got little spikes, probably two stars causing that explosion. Called a cocktail glass because it looks like a slice of lemon in a cocktail glass. This one here is a little dumbbell. This one can be seen in Perseus. You get the red glow from hydrogen alpha and the blue-green glow from O3. Now, this is a star-forming region, the Swan Nebula, low down in the southern sky in Sagittarius. It's about 15 light years in diameter, and it has an estimated solar mass of about 800 suns. So this is a region of star birth. Going further on out, we come to Andromeda Galaxy. Mike Curran took a nice picture of this last night through a fairly cloudy sky. This was taken under reasonably clear skies. So bear in mind, this is the nearest galaxy to our Milky Way galaxy. It's 2.25 million light years distance. Alex will show you how to find this in the sky in the planetarium in a little while. But of course, 1 light year is about 6 trillion miles. This is, of course, the furthest object you can see with the naked eye. It has 2 little companion galaxies here as well around it. And the other intriguing fact is that the Milky Way will collide with this galaxy in about 5 billion years. So how to find Andromeda? You can either find the square of Pegasus, jump 2 stars to the left, to the east, 2 stars up, and you see this little fuzzy patch here, or you can use the right-hand V of the W of Cassiopeia, which points to it. Okay, now go even further on out beyond Andromeda Galaxy. We're coming out to a distance of 40 million light years. This is a very distant galaxy in Pegasus. It's actually called the Milky Way's twin. So if you look back, if you were on a planet and star on this galaxy and you look back at our Milky Way, this is a sort of sight you would see. These other little galaxies surrounding it are not actually companion galaxies, but these are more remote. They're about 300 million light years further away. This galaxy is probably a little bit bigger than our Milky Way, 120,000 light years. Our Milky Way is about 100,000 light years, but is regarded as the Milky Way's twin. Other galaxies we see, again, this one in Andromeda, about 40 million light years away. This is seen edge-on. We call this an edge-on galaxy. Again, 120,000 light years from end to end, composed of 320,000 million stars. Patrick Moore, the late Patrick Moore, used to describe a galaxy as 2 fried eggs laid back to back. Now you can see what he meant. Here's the yolk of the egg, and the disk is the white of the egg. But also, when you see a galaxy edge on, you see this dark line. This is the dark dust layer. This is from which new stars have been created. Even further out now, we're at 300 million light years distance. We've come to a region of space where the galaxies themselves are appearing in groups. And this one is called Stephan's Quintet, a little group of 5 galaxies, but this galaxy is a foreground object. So it's showing a lesser redshift than the other companions. Now, redshift gives us a measure of a galaxy's distance, and it's how we explain how vast the universe is and how it is expanding. This is called a face-on spiral galaxy. So we saw NGC 891, we saw it was edge-on. This is what a galaxy would look like seen from above. We've got the core of the galaxy, which is all yellow stars, and the spiral arms of a galaxy of these young blue hot stars. Some galaxies have barred. So this is what we call a barred spiral. There's a bar from which the spiral arms come out. This one's aptly named the Superman galaxy. Okay, coming closer to home, we can look at the sun. The sun goes obviously through an 11-year sunspot cycle. After quite a quiescent period, last year it began to wake up, and we're now getting a lot more sunspots appearing on the surface. This is the sun taken through what we call a hydrogen alpha telescope, filters out most of the harmful radiation, and is looking at the sun in what we call hydrogen alpha light, the red light of hydrogen. You can see the mottled surface of the sun. You can see these dark little areas are the filaments. These are solar prominences seen from above. We've got little dark sunspots, and the bright areas are solar flares. These are vast explosions on the sun that throw off 1 million tons of matter, 1 million miles per hour. And this one is facing the Earth. That material will arrive at the Earth in 2 or 3 days. It will interact with our magnetic field and cause a wonderful northern lights, the aurora borealis. Looking at the solar prominences, we can see all this activity recently. These are huge tongues of hot plasma, solar tornadoes. You can see this twisting around. This is plasma rain. This is plasma falling back onto the sun. Here's a sunspot with an active solar flare. This bright area here is actually eruptions on the sun. And again, here are the filaments. So that is all I want to say at the moment. So we will stop sharing that. We put the lights on again, thanks. And so, any questions you want to put for me at this stage? Okay, folks, what we're going to do now, people on YouTube, I'm going to hand you over to Dave Alexander. If everyone in the audience would like to follow Alex, who's going to give you a planetarium show. Thank you very much.
Thank you.
We can use various filters on the camera stand to filter out the light, street lights.
Doesn't prove matter.
Yeah, it does, there's a lot of arguments for keeping
Much understood.
light sources reflect on the ground and not up into the atmosphere.
And it makes like telescopes necessary.
Yeah.
Oh, good evening, everybody. I've taken over from David Strange now, unlucky for you lot. Sad to report that at the moment, the weather conditions outside are pretty awful. So anyway, I and shall just give us a minute, just get ourselves sorted. Hang on, hang on, hang on. Right, might be a good time to make yourself a cup of tea and go for a comfort break while I get this thing sorted here. You're not going in there with them?
I'll be your audience.
Okay. Right. Is that a torch that works? Yeah. Ooh. Can I unplug your
Oh, yeah, do, yes. Just
oh, hang on. No, don't pull it out. Corrupted my disc last time. Oh, did I? What's like PowerPoint? Yeah. Oh, hang on a minute. Oh. Okay. Right, I've spoken to Mike Curran. Okay. Okay, all right. Just Mike's offered to, yeah. Right, let's just, can we check this now? Okay, that's David's. Just talk amongst yourselves. Oh. Right. Okay, good evening, everybody. Sorry about that. To anybody of you watching on the internet, just excuse me a second. If you were here last night, apologies, you're going to get the same video again. So I just need my gin and tonic, otherwise I can't function. This is being done in conjunction with the Sidmouth Science Festival Science Week, which it runs until the 15th of October, which culminates with the Family Fun Day that you can see on the image here. Okay, so this is in partnership with the Lockyer Observatory and the Sidmouth Science Festival. Tonight, you've already seen David Strange do his talk. You've already seen David Strange do his talk, and now you've got me. I'm Dave Alexander. Right, let's just move Mike out of the way. We've got Mike Curran on the line. Mike will show some of his images. I'm just going to do a little talk first of all, Mike. I'll just rattle through some pictures from last night, and then when you're ready, give us a thumbs up, Mike, and we'll go over to you.
Okay.
Okay.
Fine. Yep.
Okay. Okay. Right, okay, we don't need domestics. Everybody knows where the toilets and the fire exits are. If you don't know where your fire exits are at home, then you're in trouble. Ignore what's happening tonight. Live streaming from 10 minutes past 8. I'm very sad to say that it is cloudy tonight, and the forecast for tomorrow night is just as bad. So we will not be able to show you any objects that you want to see that are above the horizon, because they're above the horizon and above the cloud. Our setup tonight would have been, we use 11-inch Celestron SCT, and we use a ZWO ASI 533 camera. This is connected wirelessly to us here in the main lecture theatre by this wonderful piece of equipment called the ASI Air, which is effectively a Raspberry Pi with a transmitter and a lot of really, really useful software loaded onto it. And yeah, we use it to stream our images wirelessly to us. We use them at home. I use one, and I love it because it means I can sit in the comfort of my own home instead of being freezing out in the garden and operate my telescope. Okay, if you were to join the membership, become a member of the NLO, the membership costs £25 a year or £40 per couple. Members' nights are every Friday. You can access us via Zoom, or we encourage you to come along. We run lots of practical sessions. But again, yeah, you can access us via Zoom every Friday night. We give training on the use of our modern telescopes, and more importantly, you will be given guidance and instruction on the older telescopes that are over 150 years old, but optically are superb pieces of equipment. And yeah, they'll give you some stunning views, particularly of the planets. There is occasionally ad hoc sessions where some of us will come up here and we send out a message to say, if you want to come up, use one of the telescopes or see what we're doing, you're welcome. And you do become, have access to some of the other interest groups, like the cosmology group, which is run by Mike Curran, who's, I think you can see Mike at the moment. It's a bit above my head. It does delve into some pretty deep subjects. They do have some pretty deep debates, but having seen Mike's briefing packs that he sends out to the people who regularly join his group, he sends out some very, very impressive stuff indeed. Very interesting. Okay, one of the big talking points at the moment is the sun. These are some pictures that I took using my mobile phone through one of our solar telescopes. I'm not worried about the sunspots. It's about this very, very large solar flare. This solar flare was absolutely massive. Fortunately, it was not pointing at us. Otherwise, we would have probably had a superb auroral display of the aurora, probably far down in, well, we do get them down here in Sidmouth. That was on the 24th of June. However, on Thursday, the 6th of July, David Strange was shown around a party of students. He went into our technology centre, which for those of you who are that way inclined is quite something to see. And our very low frequency detector detected a massive solar flare. This was also picked up by another member, Dave Jones in Chard, about 25, 30 miles away. He detected it as well. And yes, that did result in a superb display of the aurora. And yes, we did actually see the formation of the aurora on our cameras that used to monitor meteors. This is a picture that was taken by one of the members here. And I find this fascinating because this is a huge sunspot that can be seen from Mars. When I asked the chief astronomer, how do we know this can be seen from Mars? It turns out that the Mars rovers constantly monitor the sun. What they are looking for is any degradation in the image of the sun, and that is an early warning of sandstorms. So they are constantly monitoring the sun as a form of forecasting the weather. More importantly, they are looking at sandstorms, for sandstorms. What do I need for astronomy? Well, you can do astronomy with your eyes. You can do binocular astronomy. You'd be surprised what you can see through a pair of binoculars. There are plenty of naked eye objects or binocular objects listed on the internet. Yeah, and very, you'd be surprised. There's lots of books, there's magazines, all sorts of things will also tell you to what to look for. We do run actually a binocular session once bi-monthly where we just go outside and we just take people and ask them to bring the binoculars to show them what they're looking at. This is an image that I took, as you can see, 15 2-minute images. So this is 30 minutes. This is a small 73mm refractor. We are seeing massive advances in optics now, and we are starting to see some really fine equipment coming onto the market at actually very competitive prices. This telescope would set you back about £650. And this is a sort of image, this is a wide field image. So this is Sadia, the star in Cygnus, and this red cloudy material is ionized hydrogen. And this telescope, using a special filter, has picked this up. Yeah. And I was telling you about the advances in optics, but now even the finder scopes, the little telescopes that you put to help you locate objects, even them, they now are produced to a very high standard. And so much so that you can actually use them in their own right to take images. And this is the same region of Cygnus Sadia. Again, this is 20 minutes worth of 60-second exposures, 20 minutes. Again, because of the type of kit you're using, you're getting a wide field image. And as you can see, a lovely area of the night sky. more detail, more hydrogen. And you can use a digital SLR camera with the sort of lens. This is an inexpensive lens, about £450. Again, you can see Saturn beautifully picked up this huge cloud now. You can start to appreciate just how big this region of ionized hydrogen is. More importantly, it's picked up something there. I don't know if you can see that very well. That's the Crescent Nebula. That is a Wolf-Rayet star. That is a star that is violently undergoing change. And that was 1360 second exposures, 9 minutes, 30 seconds in total. So if you're going to go for longer exposures, then you are going to pick up more detail. Even the basic lens that you get normally that comes with the camera, the digital SLR camera, even this, just give it a go and just see what you can get. You'll be quite impressed, I think, with the results. This is a 25-second exposure, which is about the maximum you can set the exposure time, or the time that the shutters open for before you get star trailing. And interestingly, down the bottom here, you picked up the Orion Nebula. You've actually picked up the Running Man Nebula. You've picked up the belt, you've picked up the Flame Nebula, and you've picked up a large group of young stars, OB stars, OB association. These are very young. And these won't live very long before they start going supernova, but not in our lifetime. This again is another picture with a digital SLR camera. And again, I picked up the Bubble Nebula. And also in this image, you've picked up Messier 52, a nice open cluster. Again, a very, very wide field image. Using a dedicated camera, you're starting to hone in on this region of hydrogen, ionized hydrogen. And again, you can start to see, in fact, you clearly should be able to see the Bubble Nebula. And this is, again, M52, clearly in the same field of view. This is a region between Cassiopeia and Cepheus, and this is made up of 60-second exposures. And this is what we would have expected to see if it was clear tonight through our Celestron C11, which really we tend to use for faint deep sky objects or small objects. And in this case, it has picked out the bubble beautifully. And amazingly, that is only 20 minutes worth of exposures, 20 60-second exposures, and we've stacked them. Right, what can possible targets for tonight? Oh, oh I'm sorry. Well, hopefully it would have been the Andromedan galaxy. We've got the spiral galaxy in Cannes Benetici, and we've got M13, globular cluster, lovely binocular object, and amazingly, this is only made up of 30-second images with a digital SLR camera. And that, that is just 15 minutes worth of exposures stacked. And when we talk about stack, it's basically stacking is taking individual frames and software placing them effectively on top of each other to bring out detail. Okay, we've got Mike. It's raining where Mike is. Mike will show you some of his pictures now that he's taken recently with his setup. Okay, Mike, so...
Okay, yep.
You okay?
Yep, yeah, I will, if I can sort out, where's, oh, share screen, there we go. Right. Right, that's just my background at the moment.
Yeah.
I wish I could take photos like that.
Yeah.
Right, I've just got a sort of selection of photos and so on. They're in no particular order or anything, but I thought what I'd do first is just show you the sort of equipment I use from my back garden. I'm right in the middle of Sidmouth, so fairly low down, and I've got a great big hill and lots of trees to the north, so I have a fairly limited takeoff. But I do have a this is my setup for a wide angle. It's a Skywatcher equatorial mount system there. The equatorial mount, but basically this axis here has got to be absolutely parallel with the Earth's axis. So when you're guiding and tracking on an object, all you've got to do is just rotate about that axis. You don't have to bother about the declination axis at all. However, you've got to get it set up first. Now, normally, what there is in this cap on the end comes off, and there is a little, well, it's almost like a little telescope, but it's actually a polar alignment scope with the markings of Polaris and the stars around it, and you can actually set your mount up with adjustments here to actually get everything aligned. Now, I can't use that, unfortunately, so what I've got is a little camera sitting on the end, which then feeds to a laptop and allows me to do the same thing, but without having to get down and twist my neck. So anyway, that's the basic system. This is it's called a Williams Optics 51. It's the model is, they call it a space cat or a red cat if you want the red version of it, and that gives fairly wide angle shots and so on. I'll show you a few of those later on. And this is actually a specialist cooled camera, ASI 533 color camera. And when you're running it, you can actually cool it down. It will actually go down to -30 centigrade. Although I tend to use it between -10, -20 most of the time. The cooler you can keep the electronics, the less noise you get into it, so the better quality pictures and so on. Then on top of it, amongst all these cables, I've got just a little mini scope here. It's only a 120 millimeter focal length, so 30 millimeter aperture. But again, I've got a little camera on the back of it, and that's what I use for guiding and so on. And the idea of guiding is that the software selects a particular star, works out how much it has to move the mount, both in declination and right ascension and so on, to keep that star directly in the center of the view. So any slight movement and so on, it will automatically adjust, and it keeps very much crisper pictures and so on. I'll show you the other side of it. This is the ASI Air that Dave was talking about. It's a little Raspberry Pi. It's a brilliant little piece of kit. It's got its own star maps in it, and it's got lots of very clever software which will control the telescope and the cameras and everything. This little thing on the top here is just a Wi-Fi access point. Because this is one of the old versions, it doesn't have an antenna on it. This then just links it into my home Wi-Fi system. So that's the basic one I use for wide angle. I'll just show you the Oh, got the wrong picture, unfortunately. I was going to show you the other setup I've got, but I'm not sure I can find it quickly. But basically, it's a similar sort of setup, but I've got a 150 millimeter Schmidt-Cassegrain scope, which is a reflection scope, and it rather than the normal I forgot the words, but anyway, right. So with this setup last night, things were a little bit cloudy, unfortunately, but I did manage to get some shots of the Andromeda galaxy it was through fairly light high cloud, so you can just about begin to see some of the dust lanes and so on appearing in here. Now, this was actually stacked within the little ASI Air module, and I think it was about 15 1 minute shots. So you get much better quality if you stack it externally using proper software and so on, but the ASI does a pretty good job, basically. And the other shot I got, I was absolutely amazed to get this right towards the end. I couldn't see any stars at all. I could occasionally see Vega, which was directly overhead, and I could occasionally see Jupiter. So it was really heavy cloud cover, but stacking 10 1 minute shots, the camera was able to pick up this through the clouds. Now this is what's called the Elephant Trunk Nebula, okay, and it was pretty well directly overhead. And the Elephant Trunk is this little area here and so on. And if I just show you this was a picture I took earlier using the C6 scope, and that's of the elephant trunk itself. So again, this was actually what's called a mosaic. I took two shots, so there was a top one and a bottom one, processed each one separately, and then merged them together to give you the complete detail. So as I say, that was taken probably about 6 or 8 months ago. Okay, just to then give you one or two other ideas. Last night, very early on, I did have a look at the comet. I don't know if Dave's actually said anything about this, but David Strange has actually got some much better pictures of that. But this is a comet called 12P Pons. Oh, I've forgotten the terminology now. But it's unusual in that it's although it's quite a long way from the sun, it is actually flaring and it seems to be outgassing. And the shots that David made this look like the Millennium Falcon from Star Wars. It has sort of two jets coming out of the back. So this was about 30 second shots, and then I stacked it based on the comet itself, which is why the stars are stretched, because there's 30 images of the stars there. Okay, so if I just run through a few of the sort of the standard things that we look at. This one is it's called M1, Messier 1. It's the the first one of the Messier catalogue and so on. And this is actually a supernova remnant. The star in the middle, you can just make it out, is a white dwarf star. A white dwarf is a star about the size of the sun, but when it gets a little bit, once it gets to about sort of 8-9 billion years old, it runs out of fuel and expands into a red giant, and then it blows off all its outer layers and then creates a nebula of gas that's expanding out from it, and it collapses into what's called a white dwarf, which is a very compact star, which is supported just by quantum effects rather than anything else. A very dense core. So this is actually called the Crab Nebula, and you can see lots of filaments and so on in there. So that's one of the favourite shots for viewing. One thing perhaps I ought to say is that you don't actually need a full telescope and anything like that. You can do quite a lot just with a DSLR and a decent lens, as long as you've got a tripod. This one I thought you might like to see. Basically, that was my DSLR, but with just a 50mm lens. Okay, sitting on the mount. This is Orion's belt. These are the three stars, Alnitak, Alnilam, and Mintaka. And what I was after was actually this effect here, which is actually called Barnard's loop. Okay, that actually is the extent of the shock waves from one or two massive supernova that occurred somewhere in this sort of region about 2 million years ago. Now, recent studies have actually shown looking at the Gaia satellite data, they've actually shown a bubble or a void in the middle, which is presumably where the supernovas went off and blew all the gas and dust and everything out of the region. And the boundaries of that are all these stars. This is the Orion Nebula, and then you've got the Flame Nebula, and you can just make out the Horsehead Nebula there. And the edge of that bubble then is a very active star formation region, and the extent of the shock waves actually is extending out into the big the Orion molecular cloud, and that's what you can see there. But as I say, that was only taken with a normal DSLR and a simple 50mm lens. So you can get quite interesting effects just with that. Just to give you an idea of what it looks like a bit more close up. This is the Flame Nebula and the Horsehead Nebula, and this here is Alnitak, and Alnilam is just in the middle of the Orion's belt, is just in the top there. So it gives you, again, this was taken with my C6 Schmidt-Cassegrain telescope. So you'll have to stop me if I'm going on too much, Dave.
Okay, Mike. No, you're doing a good job, Mike.
Okay.
I've just been and had a look outside, Mike. We've got heavy rain here.
Yeah. We've got rain here as well now. So
yeah, I would say, Mike, give it another 5 minutes.
Okay.
Then we'll if it doesn't look like it's improving, we'll call it a day.
Yeah, okay. All right.
Yeah.
Well, let me just nip through a few more interesting ones. I think you've shown this is M13. This is a globular cluster. It actually orbits the Milky Way. I think it's about 25,000 light years out, and so on. But it's a very dense globular cluster. If you get some really close-up pictures and so on of it, you'll find that most of the stars are red stars. Most globular clusters actually are very old, and most of the stars are actually aging. And as a star gets older, it gets redder and so on. However, there is a scattering, particularly towards the center, of what's called blue stragglers. And these are what appear to be very young, bright blue stars. Now that shouldn't happen in a cluster, because, as I say, most of the stars are formed around about the same time and the age. And what they believe is happening is that because this is such a dense cluster, collisions between stars are quite common. And when two old stars collide, the resulting star that's formed actually appears to be blue. It gives it a new lease of life. So they're called blue stragglers. Those, which yeah. Okay. This is the M16 Eagle Nebula. It's the pillars of creation. These here are the actual pillars of creation that the Hubble view or show got some beautiful shots of, and the James Webb Space Telescope has given some even better ones. So I'd advise you to look those up, and they really are brilliant shots. Another
One more, Mike. One more.
Yeah, okay.
Okay, go out with a bang.
I'll give you two more.
Okay.
There's that one, which is the Dumbbell Nebula.
Lovely.
Okay, and of course this is the M51, which is the Whirlpool galaxy. This is about 127 million light years away, and it's the first galaxy, well, the first time they've actually been able to identify a planet in another galaxy. It was somewhere around this sort of region. So again, that was an interesting one. So I think, well, apart from, yeah, I can go on all night. So
yeah. Okay.
All right.
We'll save some for tomorrow night, Mike.
Okay, fine.
Okay. The weather forecast is poor. It's raining hard here. The cloud predictor is showing that we've got heavy cloud now all night, lots of rain on the way. So I'm going to say good night to everybody, and thank you for those of you that have come on and watched us. We will be back tomorrow at 7:30, again as part of the Sidmouth Science Festival. You're welcome to tune in. The forecast is for heavy rain, a belt of heavy rain to pass through, but it's looking like more than likely that rain should clear us, and hopefully behind it we should get some breaks in the cloud. So hopefully we will be able to show you something. Certainly last night, Mike mentioned the Pons Brook, I think it is, Millennium Falcon comet. We did see that last night. It was quite superb. So yes, anyway, so thank you once again. Thanks, Mike, and thank you, everybody. And hopefully clear tomorrow night. We'll see you tomorrow night. Good night, everybody.
Okay.
Good night, Mike.
Good night, all.